This video is to summarize what we have learned in Investigation 3A. So in Investigation 3A, we dissect lots of different figures such as trapezoid. We dissect the trapezoid and change it to the rectangle, or make rectangle out of parallelogram, or make a scaling triangle out of rectangle, or something like that. We have learned a lot, and also we went over some words. Instead of saying slide, we say translate. Instead of say flip, we say reflect. And instead of turn around, we say rotate in geometry. We came up with lots of scissor congruent figures. In other words, let's say we have trapezoid, and if you take the midpoint and if we cut it through, and if we rotate it, we can make parallelogram. And these two figures are scissor congruent because it's congruent in terms of that's the definition of scissor congruent. Cutting a shape into pieces so that you can rearrange to form a second shape, and we call that scissor congruent shapes. And we made sure that how do we know that this side will fit with this side? This side we have to make sure that this side will perfectly match with this side. And how can we make sure those things? If we take the midpoint here, the lengths of these two, this segment and this segment, will be exactly the same. Therefore, it attached perfectly. Another thing we made sure was that how do we know the top base of the parallelogram or any figures are straight line? We want to make sure that these two angles that next to each other makes 180 degrees. And in another case, we have to make sure that the bottom base has to be lie on a straight line. So these two angles must be 180 degrees as well. But how do we know these two will be 180 degrees? Well, first of all, let's call that angle 1 and 2, and this forms angle 1 plus angle 2 is 180 degrees, because otherwise this is not a straight line. Then if this is not a straight line, this is not a trapezoid, because if it's not a straight line, we'll have another vertex right there. It will look like something like this, or this. And that's not a trapezoid, that's a pentagon, because we have 5 segments. If you turn it over, angle 1 and angle 2 still be next to each other. Therefore, it's going to be 180 degrees, because we know angle 1 plus angle 2 is 180 degrees from the previous one. And also angle 3 and angle 4 is 180 degrees. And if we bring that back, we have, if you turn that around right there, angle 4 will be there, and angle 3 will be here. Now, we're going to use the, angle 3 will be there, sorry. No, that's not it. Angle 3 will be here. Okay? How do we know the bottom base will be 180 degrees? Well, we know that right there, this angle is angle 4, because this line and this line is parallel to each other, and these two are congruent angles. And also this is angle 3 as well, because it lies on the parallel lines because of the parallel PAI theorem. So we have angle 3 here and angle 4 here. Okay? Now, we also know that this right there is angle 2, and this is angle 1 because of that reason. Therefore, if you turn it over, we'll have angle 1 and angle 2 next to each other. Now, that forms 180 degrees. And also, this tells us that opposite angle of parallelogram are congruent. See, opposite angles are exactly the same. And we also we learned how to make a rectangle out of scalene triangle. So here's a scalene triangle. Take the midpoint, cut it, get that top the triangle, cut it from the top vertex, draw a perpendicular line and cut along, and then put those on the other side, and that's going to make the rectangle. Again, we have to make sure that how do we know that top base of the new rectangle will be 180 degrees? How do we know this side match with this side perfectly, and so on and so forth? And we can use the same argument that we have from here. And we learned the midline theorem, which is if you take the midline of any triangle, those two lines will be parallel to each other, to the bottom base or the base or the side, and then the length of the midline will be exactly a half of the side parallel to that midline. And we extend that idea so that we concluded that, okay, if we take the midline of a trapezoid which parallel to the top base and the bottom base, we learned that the midline is a half of the sum of top line, top base, and the bottom base. So in other words, if you add top base and the bottom base, okay, that length will be exactly twice as. So that's about it.